Hello everyone, welcome to Math is Fun. Today we're going to talk about rational numbers and terminating and repeating decimals. Before we're going to discuss about rational numbers, let's discuss first what is a natural numbers. When you first learn to count using the numbers 1, 2, 3, 4, and so on, you were using the members of the set of natural numbers or counting numbers. This is the set of natural numbers, the set of 1, 2, 3, 4, and so on. If you add 0 to the set of natural numbers, the result is the set of whole numbers. So this is the set of whole number. We have the set of 0, 1, 2, 3, and so on. When we say whole numbers, start with 0. When we say natural or counting numbers, start with 1. Whole numbers and their opposites make up the set of integers. So this is an example of the set of integers. We have the set of -3, -2, -1, 0, 1, 2, 3, and so on. So when we say integers, these are numbers from the negative to positive, including 0. So the natural numbers or the counting numbers together with the whole numbers as well as the integers make up the rational numbers. So when we say rational number, it is a number that can be written as a ratio of two integers in which the denominator is not 0, a over b, where a and b are integers and b is not equal to 0. What happens if b is equal to 0? Alright, it becomes undefined. So when we say rational numbers, these include fraction, decimal, percent, together with the integers, whole numbers, and counting or natural numbers. Now we know what is a rational number. Now let's proceed to repeating decimals. When we say repeating decimals, they are decimals in which one or more digits repeat. Bar notation is often used to indicate that the digit or group of digits repeats. While terminating decimals, they are decimals that have a finite number of decimal places. To understand further what is repeating and terminating decimals, let's study the following examples. First, we talk about repeating decimals. So we have here, write 2/3 as a decimal. So 2/3 means 2 divided by 3 or divide 2 by 3. So let's divide 2 divided by 3. What is the answer? Alright, 2 divided by 3 cannot be, or we put our placeholder 0. 0 times 3 is equal to 0. 2 minus 0 is equal to 2. Then we add the decimal point to our dividend and also we copy it into our quotient. Then we're going to add 0. Bring down 0. 20 divided by 3 is equal to 6. 6 times 3 is equal to 18. 20 minus 18 is equal to 2. Then we can add another 0. Bring down 0. 20 divided by 3 is equal to 6. 6 times 3 is equal to 18. 20 minus 18 is equal to 2. Look at our remainder. It is still 2. Our answer is 0.66. Then we can put a bar notation on top. The repeating digit is 6. if you were to continue dividing, the quotient would be 0.666666 and so on. So this is an example of a repeating decimals. Next, let's talk about terminating decimals. For example, write 3/4 as a decimal. So 3/4 means 3 divided by 4 or divide 3 by 4. So let's divide. 3 divided by 4. So what is the answer? Alright, 3 divided by 4 cannot be. And we are going to put our placeholder 0 on top of 3. Then let's multiply. 0 times 3 is equal to 0. 3 minus 0 is equal to 3. Then we can add a decimal point to our dividend. And also, we are going to copy into our quotient. Then add 0. Bring down 0. 30 divided by 4 is equal to 7. 7 times 4 is equal to 28. 30 minus 28 is equal to 2. Then we can add another 0. Bring down 0. 20 divided by 4 is equal to 5. 5 times 4 is equal to 20. 20 minus 20 is equal to 0. Look at the remainder. What is our remainder? Alright, the remainder is 0. If we're going to change 3/4 to decimal, the answer is a terminating decimal. 0.75 is a terminating decimal or 75 hundredths. Next, we're going to discuss about repeating decimals as fractions. For example, write 0.6 with a bar notation on top of 6 as a fraction. So, the first thing that we're going to do is we're going to assign a variable to the value of the decimal. So, we have n is equal to 0.666 and so on. So, in this example, we use n as our variable. Next, multiply each side by a power of 10. Then, the next step, in multiplying by 10, moves the decimal point one place to the right. So we have here 10 times n is equal to 10n. 10 times 0.666 and so on is equal to 6.666 and so on. After this, subtract the original equation to eliminate the repeating part. So we're going to subtract by the quantity of n is equal to 0.666. And the difference is equal to 9n is equal to 6. Okay, we just simplify. 10n minus n is equal to 9n. 6.666 minus 0.666 is equal to 6. Next, we're going to divide both sides of the equation by 9. Then, 9n divided by 9 is equal to n. Then, 6 over 9. We can reduce this fraction to its lowest term by dividing 3 both numerator and denominator. 6 divided by 3 is equal to 2. 9 divided by 3 is equal to 3. So, n is equal to 2/3. So, we reduce it to its lowest term. And in this example, the fraction form of 0.6 with a bar notation on top of 6 is 2/3. I hope that you understand our lesson for today, and thank you for watching.